At the center of the Milky Way, 26,000 light-years from Earth, there is a black hole 4.3 million times the mass of the Sun. We have watched stars orbited at 3% of the speed of light, and in 2014, we watched something fall toward it. Its name is Sagittarius A star. For most of the 20th century, we did not know it was there. The center of the galaxy is hidden behind thick clouds of gas and dust. In visible light, it is completely obscured. We only found the black hole by looking in radio waves and infrared, which pass through the dust. In 1974, Bruce Ballack and Robert Brown detected a bright, compact radio source at the exact center of the galaxy. It was unusually small and unusually still. It did not move across the sky the way stars do, because it sat at the pivot point everything else orbits around. That stillness was the first clue.
The decisive evidence came from watching the stars closest to it. Two teams, one led by Reinhard Genzel in Germany, one by Andrea Ghez in California, spent decades tracking individual stars in the galactic center with infrared telescopes. One star, called S2, completes an orbit every 16 years. At its closest approach, it whips around the central object at roughly 3% of the speed of light. From the shape and speed of that orbit, the math is unforgiving. To hold S2 on that path, the central object must contain about 4.3 million solar masses, packed into a region smaller than the orbit of Mercury. Nothing known to physics can do that, except a black hole. The measurement was precise enough, and the conclusion certain enough, that Genzel and Ghez shared the 2020 Nobel Prize in Physics. Then, in 2022, the Event Horizon Telescope, a network of radio dishes spanning the planet, released a direct image, a ring of light around a dark center, the shadow of the event horizon itself. We were no longer inferring the black hole from the stars around it. We were looking at it.
Sagittarius A star is real. It is measured, and it is the gravitational anchor of the entire galaxy. The question is not whether it exists. The question is what it does. A supermassive black hole is not a cosmic vacuum cleaner. It only pulls in matter that gets close enough, within a region called the accretion zone. Most of the time, Sagittarius A is starving. It accretes a tiny trickle of gas, which is why it is so faint compared to the monsters at the centers of other galaxies. But occasionally, something falls toward it. And in 2011, astronomers spotted exactly that. A cloud of gas, several times the mass of Earth, was on a trajectory that would carry it to within a few hundred astronomical units of the black hole in 2014. They called it G2. The prediction was dramatic. As G2 plunged inward, tidal forces should whip it apart, and the shredded gas should spiral down, heat up, and produce a flare bright enough to study in detail. Cosmic fireworks, on a schedule, for the first time. The world's telescopes watched. 2014 arrived. G2 made its closest approach. And almost nothing happened. G2 was stretched, but it survived its passage largely intact. The flare never came. The anticlimax was its own discovery. It suggested G2 was not a simple gas cloud, but probably contained a star at its core, holding itself together with its own gravity against the black hole's tides.
That does not mean Sagittarius A is inert. It flares constantly on a smaller scale. In X-rays and infrared, it brightens for a few hours at a time, several times a day, as clumps of matter in its immediate vicinity heat up and fall. In 2019, one team recorded the black hole becoming, briefly, 75 times brighter than its normal infrared baseline, the most dramatic flare ever observed from it. They did not have a confirmed explanation. These flares are tiny by cosmic standards. They are the black hole nibbling, not feeding. But they prove the machinery is intact. The accretion disk, the heating, the relativistic physics, all of it is there, idling. Sagittarius A is a dormant engine, turning over slowly, waiting for fuel.
Here is the part that changes the story. Sagittarius A star is quiet now. It has not always been quiet. In 2010, the Fermi Gamma Ray Space Telescope discovered two enormous structures extending above and below the plane of the galaxy. Bubbles of high-energy gas, each stretching about 25,000 light-years from the center. They are now called the Fermi bubbles. The leading explanation is that they were inflated by a massive outburst from the galactic center, either a burst of star formation or a feeding episode of Sagittarius A star a few million years ago. There is more. In 2019, astronomers found evidence of a separate, more recent event, a flare of radiation so powerful it lit up a stream of gas far outside the galaxy, called the Magellanic Stream. The timing points to an eruption from Sagittarius A star roughly 3.5 million years ago. In galactic terms, that is yesterday. Our early human ancestors were already walking upright in Africa when the center of our galaxy briefly blazed.
When a supermassive black hole feeds in earnest, it becomes an active galactic nucleus, one of the brightest sustained objects in the universe, channeling the energy of infalling matter into radiation and jets that can outshine all the stars in the galaxy combined. Sagittarius A star has the mass to do this. It simply lacks, at the moment, the fuel. So is it a threat? In any practical sense, no. We are 26,000 light-years away, far outside the reach of anything it does. Even during its past eruptions, Earth was untouched. The danger of a supermassive black hole is local to its own neighborhood, not galaxy-wide. But the architecture of our galaxy is built around a dormant monster. It has erupted before. It will, on long timescales, get fed again by a gas cloud, a disrupted star, an infalling companion. When that happens, the center of the Milky Way will light up the way the centers of other galaxies already do. We will see it from a safe distance, the way we are seeing everything else. The stars at the center keep orbiting. The black hole keeps idling. And every few hours, it flares. A reminder that the quietest object in the galaxy is also the most powerful, simply waiting for something to fall.